Hello and welcome to this video. I want us to study some basic techniques of differentiation, and the first one that we're going to look at is the constant rule. So all you need to know about this rule is that the derivative of any constant k is supposed to be 0. So let's look at a few examples. The derivative of 5 is supposed to be 0 since 5 is a constant. The derivative of 2 is supposed to be 0 since 2 is also a constant. The derivative of pi is supposed to be 0 since pi is also a constant. Remember, pi is 22/7. The derivative of exponential 5 is supposed to be 0 since e is a constant and 5 is also a constant. Remember, e is approximately 2.718. The derivative of pi raised to e is supposed to be 0 since pi is a constant and e is also a constant. Alright, let's look at the next technique, that is the power rule. If we have a function y is equals to ax raised to power n, the derivative of this function dy over dx will be, so the first thing that you need to do is to multiply this power n by the coefficient a to give us an, and then subtract 1 from this power n to give us n minus 1. So we can look at a few examples so that you can understand better. If we have a function y is equals to x raised to power 3, the derivative of this function dy over dx will be, so in this case the coefficient is 1. So we're going to multiply the power 3 by 1 to give us 3, and then subtract 1 from 3 to give us 3x squared. Alright, y is equals to x raised to power 6. The derivative of this function dy over dx will be, so you need to multiply 6 by the coefficient 1 to give us 6x, and then subtract 1 from 6 to give us 5. Alright, if we also have another function y is equals to 3x raised to the 4th power, the derivative of this function dy over dx will be, so the coefficient in this case is 3. So we need to multiply the power 4 by the 3 to give us 12x, and then subtract 1 from 4 to give us 12x cubed. If we also have another function, f of x is equals to 1 over x cubed, the derivative of this function will be, so this is a fraction. So the first thing that we need to do is to change the form of this function, and we're going to make it f of x is equals to x to power negative 3. So you just move the x to power 3 up here and then put a negative sign in front of the power 3. So the derivative now of this function will be f prime of x will be, so negative 3, and then subtract 1 from negative 3 to give us x to power negative 4. So we can now decide to change it back to the initial form. Initially it was a fraction, so we need to change it back to a fraction. So it will be negative 3 over x to the 4th power. Alright, if we also have another example, y is equals to 1 over 3x to the 5th power. So this is also a fraction. So we need to change the form of this fraction. So instead of being in this form, we are going to make it y, or let me write this. We're going to make it y is equals to 1 over 3 x to power negative 5. So now being in this form, we can now easily find the derivative of this function. So the derivative dy over dx will be, so you need to multiply the negative 5 by a third to give us negative 5 over 3, and then subtract 1 from negative 5 to give us, sorry, let me write this properly, to give us x to power negative 6. Alright, let's look at another example. If you have a function, alright, sorry, let us first of all change it back to the initial form. Initially it was a fraction, so it's going to be negative 5 over 3x to power 6. So we can move on to the next example. If we have a function y is equals to 3 over 2x to the 6th power. So to find the derivative, we need to change the form of this equation, and we're going to make it y is equals to 3 over 2x to power negative 6. So now being in this form, we can now easily find the derivative dy over dx, which will be, so we need to multiply the 3 over 2, multiply it by the power negative 6, so, and then subtract 1 to give us negative 7. So when you work out this, we are going to get by 2 1 by 2 negative 3, so to give us negative 9x to power negative 7. So we now change it back to the initial form. Initially it was a fraction, so it's going to be negative 9 over x to the 7th power. Alright, let's look at another example. Y is equals to the root of x. So y is equals to the root of x. So the first thing that we're supposed to do is to change also the form of this function. So we are going to make it y is equals to x to power a half. So x to power half, or rather the root of x, can also be written as x to power a half. So we can now proceed to find the derivative. Dy over dx will be, so it will be a half x, and then subtract 1 from a half to give us negative a half. Alright, let's look at another example. If we have a function y is equals to the cube root of x raised to the 4th power, so what will be the derivative of this function? So we need to change the form of this function. So instead of being that way, we're going to make it y is equals to x to power 4 over 3. So the 3 becomes the denominator and the 4 becomes the numerator. So we can now proceed to find the derivative. Dy over dx will be, so this will be 4 over 3 x, and then subtract 1 from 4 over 3 to give us a third. Alright, let's look at another one. Probably this will be a more complex one, but it's not hard. We're just going to apply the same principles that we have discussed. So y is equals to 7x to power 5 minus 3 over x to the 7th power plus x, or rather the 4th root of x raised to the 5th power. So you can first of all pause the video, try to work it out yourself. So the derivative of this function dy over dx will be, so for this part we're going to multiply the 5 by the 7 to give us 35x, and then subtract 1 from 5 to give us 4. Then for this other part, we have to change the form of this part. So we're going to make it 3x to power negative 7. So we can now find the derivative, which will be negative 21, and then subtract 1 from negative 7 to give us negative 8, x to power negative 8. So we then now change it back to the initial form. We make it a fraction as it was initially. So it's going to be negative 21 over x to the 8th power. So we have negative 21 over x to the 8th power. So for this other part, we also need to change the form of this part. So we're going to make it x raised to power 5 over 4. So we can now find the derivative, which will be 5 over 4x, and then subtract 1 from 5 over 4 to give us a quarter. So this will be 5 over 4x raised to power a quarter. So this will give us 35x to the 4th power. So this will give us a positive 21 over x to the 8th power plus 5 over 4 x to power 1 over 4.